engineering and mechatronics engineering students as well. So first of all, I'd like to give you the brief outline about the discussion, what I'm going to discuss in this video, and then I'll discuss about those topics one by one precisely to make you understand about these different things in the leveling, right? So starting with the outline of the leveling, I'm going to start with the discussion of the leveling with its introduction, and introduction is now available with its aim, the objectives, you can say the definition of it, the applications of leveling. Then also I'm going to discuss about various important terms in terms of the introduction of leveling, because these terms are the technical terms and I'm going to make use of these terms frequently in my discussion, so it is always necessary to understand such technical terms in the advance or in the prior to understand well about the original concept, right? So I'm going to discuss about some important terms very used in the leveling frequently. Then I'll try to discuss about the instruments used in the leveling, right? The commonly adopted instruments used in the leveling. I'll give you some idea about some other type of instruments as well. One may use those instruments as well for the leveling. And also I'm going to discuss about the components of these instruments and the working of it, right? After that, I will try to brief you about the adjustments, because when you try to use those instruments for the actual leveling work, you need to have certain adjustment before taking the reading or before taking the observations, right? So how to carry out those adjustments with your instruments, I'm going to discuss about those adjustments as well. Then I'll try to discuss about, you can say, the various types of leveling, and as you see the leveling is not a small thing. It is very vast field or vast top part of the surveying, you can say, and it is now available in so many variety of types, rather classification. So I'll give you the broad classification of leveling. Then afterwards I'll try to discuss about some few more technical terms of the leveling, which is now going to help you in understanding the application part of the leveling. And here you can say we are ended with the first part of the leveling. The second part will be the application of the leveling, and which is now available with the important, again, other technical words or other technical definitions. Then we'll discuss about these different methods of leveling, because you have to adopt certain methods for carrying out your leveling work. So which are the various methods used for the leveling? I'm going to show you the certain examples and its solution based on such methods, so that you can understand about those methods precisely and the application, how it is to be utilized on real field. And after that I'm also going to discuss certain more cases about leveling, where you have to, let's say, one has to work on some different circumstances or conditions, let's say leveling on sloping ground. So I'm going to discuss about those variety of conditions as well. And lastly I'm going to discuss about the errors in leveling, because there has to be certain analysis on the errors one may found in terms of leveling work. So which are the various types of error one can encounter during the leveling work, I'm going to discuss about those errors as well. And that's how we'll try to finish the discussion of leveling. At the end, as a bonus, I'll try to give you idea about the other important topics in context of leveling only, and that topic is termed as your contours and contouring. So I'll brief you about that particular topic as well. So that's how this discussion will follow. So that was all about your outline of this discussion. So without wasting time, let's get started. So starting with the introduction of the leveling, right? So I'll start my introduction by simply giving you the understanding about this branch as well as some other branches as well that might be you have studied before. So the other branches, you can say, is your linear measurements, then angular measurements, right? And the third, you can say, leveling here. So the major difference between those two branch and this one is that the observations only, so, or where you are going to take your observation. In linear measurements and in angular measurements, the observations are always carried out in horizontal plane, right? So in linear measurements you will try to measure the distance on the ground, right? And that has to be done on horizontal plane. And in angular measurements, again, you will try to determine the angle between 2 points on the ground, but again that angle will be the horizontal angle, right? However, if you want to determine the angle between 2 points, but if it is a vertical angle, then it will come under your vertical plane and not the horizontal plane, right? So the first two branches, linear measurements and the angular measurements, are always working in horizontal plane. But here the leveling is different than those two, and here the measurements are always taken or carried out in vertical plane only. That is the important point you have to keep in your mind. So whatever discussion I'm going to have about different measurements or the readings in my discussion, make sure it is in vertical plane only and not the horizontal plane, right? So starting with the definition of the leveling, leveling is something, it is defined as an art of determining relative heights or the elevations of different points. Now if you remember, if you know the definition of surveying, it is something similar as like this leveling. The definition of surveying says this is to determine the relative positions of different points on or below the surface, right? So positions, if you want to determine of different points, you need to have certain measurements, and that's how you are working in horizontal plane and vertical plane. So the vertical plane part is here to be discussed in leveling, right? So it is the art of determining relative positions or relative heights or the elevations of different points on or below the surface. That is termed as the leveling, right? And it deals with the measurements in vertical plane, as I just discussed with you, right? So this leveling is actually have two different objectives, and as you can see here on the screen, these objectives or applications what I have mentioned here is something you can say they are the elaborated version of the original objectives of the leveling. So that I have not mentioned here on the screen, but I'll discuss with you first of all, right? So these four you can see here on the screen are more termed as the applications and not the objectives. So what are the objectives that I'll discuss with you now? The first objective says that is to find the elevations of given points with respect to given or assumed datum, right? Don't get confused here, I'll help you every time. So first says that to find the elevations of the given points. So here you have given certain points and you need to determine the elevations of those points. But how you will determine the elevation, or how we will define those elevations rather? Let's say if this is the point and you need to, you're measuring the elevation of the point, let's say it is something you can say 5, but the point is on the ground, but how you can say that the elevation of that point, right? So you need to determine the elevation, or you can define the elevation of that point with some reference, or by some reference, right? And that reference is termed as the datum. I'll discuss about datum lately in terms of the various terms, various definition, various technical terms used in leveling, right? So I'll discuss there with about the datum, but don't get confused here. The first objective says to determine or to find elevations of given points with respect to given datum. The second objective says to establish points at a given elevation or different elevation with respect to given datum. So now make sense. The first objective says to determine elevations of points which are already given to you, which are already known to you, and simply you are determining the elevations with help of some reference. Like let's say some point of reference is somewhere here on one corner of your area, and you will say the point in the other corner of the area. So that point in the other corner of the area is somewhat higher or below with certain value of elevation from that particular point in that first corner, right? So that's how it will work. And the second objective says that here you have given the elevations and you are establishing a point, or you are simply establishing a point at that particular given elevation, or it may be at different elevation, and that is your second objective, right? So these are the two objectives of the leveling, and if you elaborate these two objectives now, as you can see here, they are going to termed as the application, right? So the applications are very simple. The first one is to prepare the topographical map or contour map. So as I mentioned in the outline that I'm going to discuss about contour in a very proper way at the end of my discussion after discussing about leveling. So here I'm not going to waste my time in discussing or give you idea about contour, right? But I'll give you simple hint of it. The contour map or topographical map is a map which is simply referred to understand the topography of area, and topography is nothing but the undulation of the area. How much slopey area is there, how much level area is there, how much you can say hilly area is there, right? And that is termed as the topography of an area. So that particular map can be prepared by now having leveling into the account. If you carry leveling, so leveling will help you in preparing such maps, right? Because you need the elevation data to define the topography. That's the first application. Second application is simply says that to determine the altitude or the reduced levels of different important points, right? So the altitude or the reduced levels are something you can say they are termed as the elevations only, But there is a small difference of reduced levels and the elevation that I'll again discuss in different terms, right? So if you want simply the application, one can determine the reduced level of the elevation of different points in that area. The third application is says that to prepare the different section of different engineering projects, right? And sections being longitudinal section and the cross section. Now longitudinal section, when you try to cut your thing along its length, that is termed as the longitudinal section, L section. And if you try to cut something across its length, or rather along its width, then it is termed as the cross section. So this particular leveling is going to help you in determining these L sections and cross sections of different engineering projects such as roads, canals, etc. The fourth application is simply to prepare the layout map. So these are some important applications of the leveling, you can see here on the screen, right? So after this introduction, I'll now try to discuss with you about the various terms which are frequently used in your leveling. So as you can see here, I have mentioned, or I have written all those important terms which are frequently used in the leveling, right? As you can see here on the screen. So the different terms are mentioned here on the left hand side and as well as on the right hand side, and in the center I have actually incorporated one figure for your understanding, right? So I'm going to discuss about these terms one by one quickly, so that we can move to the other important topics of the leveling, right? So the first one is a level surface, right? There is always a confusion. We are always saying the level surface as the horizontal surface, right? But this level surface, horizontal surface and vertical surface, these three are actually different. If you are working in actual field that is on the surface of the earth, then these three has to be different, right? So the first one is a level surface. So level surface is something you can say it is defined as a curved surface which at each point is perpendicular to the direction of gravity at the point, right? Again, it is simply a curved surface which at each point it is perpendicular to the direction of gravity at that considered point only. So you understand here from the screen or from the figure, this one, this particular line or this particular surface is termed as a level surface, right? So the best example of level surface is a still water, and it is truly a level surface. So any surface which is parallel to mean spheroidal surface of the earth, as you can see here, this one, this is the mean spheroidal surface of the earth. So this level surface is the parallel to this mean spheroidal surface of the earth, and that's how it is termed as a level surface, right? Because as we know that the earth is spheroidal, and that's how the surface of the earth is spherical. Whatever the level surface you will see, it is also going to be spherical in shape only. But for us, let's say for reasonably smaller distance with your naked eye, you will try to find it as the horizontal one, but that's not considered as the horizontal. They are always considered as the level, or rather the best word is to use here is the uniform surface, right? So if any particular line which is lying on the level surface is termed as your level line, right? So what's the horizontal surface or horizontal plane then? It is the plane through a point tangential to the level surface at that point. So as you can see here, this top one, this is a horizontal surface, right? So it is now tangential to your level surface through a point. Let's say this is the point somewhere here, right? So this horizontal surface is always tangential to the level surface, and you can see here it is therefore perpendicular to the direction of the gravity through that point. So this vertical line is something you can consider as it is indicating the direction of the gravity. So what is the difference between this level surface and horizontal surface here? That this level surface is always normal to this vertical surface or vertical plane, whereas a horizontal surface is always perpendicular, and there is a difference between normal and perpendicular, as you know, right? So and now any line which is available on this horizontal surface is also termed as horizontal line, right? So that's how you understand the difference between level surface and horizontal surface. And the third one is now vertical surface and vertical line. So what is vertical surface and vertical line then? Vertical surface is a surface which is passing through a vertical line. And what is vertical line? Vertical line is something, the line which is running along the direction of gravity, along the line or along the plumb line. Also it is termed as the plumb line, which is nothing but is the direction of gravity, right? So that is your vertical line, as you can see here in this figure, right? So that is termed as your vertical surface and vertical line. So now you mark the difference between these three surfaces and three lines, right? Now moving next, the next particular topic or next particular term which is used here in leveling is termed as a datum. But here, as I mentioned, is datum surface and datum line. So datum is any surface you can say to which elevations are referred, right? So you can say it is the reference point. So what do you mean by reference point? If you want to define the elevations of, let's say, some point, you need reference that there is this point is available at this much elevation above or below to the surface, but from that surface should be known to you, and that surface from the reference of which you are going to determine or define the elevations of different point is termed as your datum, right? So generally, if you say if you understand here, the datum is generally taken as or which is fixed for our work, and in our case this datum is always considered as the mean sea level. Why mean sea level? Because it is the most common and convenient datum and which is internationally adopted accepted one, right? So what does it mean? So different countries will try to take the sea levels or nearby sea levels as the datum planes for the calculations of the elevations of different points in their areas or in their country. So what does it mean? Let's say if you talk about our country, India. So India takes the sea near Mumbai as its datum for calculation of reduced levels. We have different places in the respective areas of the country. At the same time, you can talk about other countries as well. Let's say the neighborhood country, Pakistan. So Pakistan takes sea near Karachi as its datum. So that's how the different countries will try to take the sea levels or nearby sea levels as a reference to determine or define the elevations of different points in their country or in their area, right? That's how this datum is used. So that is termed as a datum surface, right? So the line, if you consider on that surface, it is termed as your datum line, right? So generally you understand here that it is often more convenient that however to assume some other datum, specifically if only the relative elevations of points are required. What does it mean? One can define the elevations of a city, one can define the elevations of certain area of the city, one can define the elevations of certain points of the area, one can define the elevations of different countries. So as you move from this top level to the bottom, from the broad level to the local, you understand or you make the difference. Let's say if you want to define the elevations of a point which is available in any particular area of the country, you will not going to take the reference as a mean sea level, right? Because it is not convenient, it is not feasible, and in that case you will try to take some other reference, or you will try to establish your reference to define the elevations of different points in that area. But however, if you understand, let's say if you want to define the elevations of a particular city, so if you have ever traveled by railway, if you have ever seen the platform board where the name of the station or the name of the city is always mentioned, on that yellow board you will find the red line, a small red line marked available at the bottom of the name of the station, and there is always mentioned as the height above mean sea level. So if you want to define certain big areas, or let's say if you want to define areas in terms of the elevation, then you will consider mean sea level as your datum or as a reference. But if you want to define the elevation of a point, then you don't consider this mean sea level, but rather you will try to consider some benchmarks, and that's how the benchmark will come into the picture, and that's the next particular term that we should discuss here. But before that, mean sea levels is to be discussed and it should be understand what is mean sea level, because that's again the confusion, because every time you will try to refer, they will always say that refer mean sea level, but what is this mean sea level actually? What does it mean? So mean sea level is the average height of the sea for all stages of the tides. So at any particular place, it is generally derived by averaging the hourly tide heights over a long period of 19 years, right? So if you average the hourly tide heights for a period of 19 years for a particular place, then that is termed as the mean sea level for that place. And that's how the mean sea level is been defined, right? And that is different for different nearby sea for different countries, right? So that's your mean sea level. So now, as I mentioned, what is benchmark then? So benchmark is relatively a permanent point of reference whose elevation with respect to some assumed datum is known. What does it mean? The benchmark is a relatively permanent point of reference whose elevation with respect to some assumed datum is known. That means it's simply defined as a fixed point of known reduced level, as I mentioned here in the red line, you can see here, right? So it is used either as a starting point for a leveling or as a point upon which you can close your check of the leveling work, right? So I'll discuss about this benchmark in bit detail, because we have different types of benchmark available, and as you can see here, I have mentioned these 4 different types of benchmark. The first one is your GTS, the second one is your permanent benchmark, then the third one is your arbitrary benchmark, and the fourth one is your temporary benchmark. Now, what is the difference between these different benchmark here mentioned, right? So I hope you understood the difference between datum and benchmark, but now you understand why there are different types of benchmarks available, right? Because let's say as you are moving from the global, let's say from broad to local, you need some more number of fixed point of known elevations, right? If you are working in a village, you can't take the reference of a point which is available in city or in nearby city or in nearby villages. You need some different form of reference available at that particular area only. That's how these different types of benchmark will come into the picture. The first one is termed as a GTS benchmark, right? And this benchmark, or they are the benchmarks which are established with a very high degree of precision and at regular intervals by the Survey of India department all over the country, right? So their position and RL's values above mean sea level, which are already located, which are already considered and which are already calculated. So as I gave you the example of Bombay, that we are considering the mean sea level of Bombay city. So that's how the GTS benchmark, that means these are the fixed points which are already been established across the country by Survey of India department centrally, and their elevations are now already mentioned and they are designated on them, and they are calculated with reference to the mean sea level at Bombay, right? So now they are available across the country. As you move away from that, you need some other reference, right? Like say if you are working in some area and that GTS of the country is available in nearby area, you won't consider some other reference, but you will directly consider that GTS as your benchmark to define the elevations of different points. But however, let's say if you are working in such scattered area or such isolated area where this GTS benchmark is not available in your vicinity, then what you need to do? One has to go for some more number of benchmarks for the conveniency, and that's how the permanent benchmark will come into the picture. The permanent benchmarks are the fixed in between GTS benchmarks, and that has to be done by the state level agency or state government departments, right? And that's maybe the railways, PWD, etc. And these benchmarks are written on permanent objects such as milestones, culverts, bridges, etc. And their value are clearly written and their positions are recorded for the future reference, and that's how the furthermore benchmarks will come into the picture, right? So these 2 different benchmarks are always available across the country, for any country you can say, right? And let's say still if you are working in certain area but you don't have that particular permanent benchmarks or GTS benchmarks are not available in the vicinity of area, you may go for some different other types of benchmark consideration, and that benchmarks are termed as your arbitrary and temporary benchmarks. So what is arbitrary benchmarks then? So these are the reference points whose RLs are arbitrarily assumed, right? So let's say if you are working for a very small amount of work, a small house construction, let's say small building construction where you need to do certain form of leveling, let's say you are working for the construction of a very small road, so then you need to consider certain RLs. But if it is a very vast project, very big scale project, then there has to be certain permanent benchmark and GTS consideration should be there to define the elevations of different points. But for small scale work, you will consider this RL or the points of known RL by assuming their RLs, right? And in generally they are assumed as 100. That I'll give you very good idea while discussing about the example part of this leveling, right? And the temporary benchmarks, so these are again the reference points established during the leveling operations, and when there is a break in work or at the end of the day's work, the value of reduced levels are marked on some permanent objects such as stones, trees, etc. They are the temporary benchmarks. So once your job is finished, you will remove that benchmark. So that's how these different things will work in the leveling, right? And that is your benchmark. So these are the different terms used, frequently used terms in your leveling, right? So I hope you understood these terms, so that you will not gonna confuse while I'm going to discuss about some more important topics of leveling further, right? So next I would like to now discuss with you about the instruments used for the leveling, right? So generally the leveling instruments are two, or commonly used leveling instruments are only two. The first one is termed as the level, and the second one is the leveling staff, right? So what is level? So the generally level is nothing but is the name of the instrument, alright, and this name of the instruments are available as you can see here. I have mentioned as dumpy level. This is one of the type of the levels. There are few other types are also available, let's say Y level, a reversible level, tilting level. I'll give you a hint about these levels at the end of this discussion, but at the same time I'll give you idea about dumpy level only, as I mentioned in the beginning that I'm going to discuss this particular leveling in context of basic civil engineering. So it is required to be understood this dumpy level here, and not the other and all different types of levels available in the market, right? So the level is something, you can say the purpose of level is to provide the horizontal line of sight, and essentially a level consists of certain parts, and these parts are I have mentioned here as a components of dumpy level, right? So which are the components? You can see here: tripod stand, leveling head, foot screws, telescope with diaphragm, bubble tube, compass, axis of telescope, and line of collimation. I'll give you a very good idea about these components, right? So here you can see in this figure these all components are already marked, right? So I'm going to discuss about this particular components one by one quickly to give you the hint about this instrument, right? So the first one is something called as the tripod stand. Tripod stand is very simple and very easy to understand from the figure only. It consists of three legs, and which may be solid or the telescopic type. What do you mean by telescopic? The height of the legs, if it is adjustable, right, you can reduce or you can increase the height of the legs, and they are termed as the telescopic, right? So it may be solid type or it may be telescopic type, but it contains three legs. That's why it is termed as tripod, and the legs are made of wood or the aluminium, and the lower ends of the legs are always fitted with iron shoes, so it is always feasible and convenient to fix the tripod legs into the ground, right? That's how this tripod stand will is work. Then the second one is the leveling head. As you can see here from the bottom, the second one, the leveling head, or which is also termed as a trivet. Now leveling head consists of two parallel plates. Now two parallel plates you can see here. The first one is known as trivet, and the second one is known as the tribe edge. So you can see here this one is a trivet and this one is a tribe edge, right? Now what are these two different plates has to do, right? So it simply they are the leveling head, that means they are the plates, right? And they have three grooves to support the foot screws. So you can see here these are the foot screws. You can see only two foot screws because this is the side view of the instrument. So the other foot screw may be there behind the one of this foot screw. So there are always three foot screws available, and these foot screws are fixed with through these grooves available in these plates, right? So these two plates are now connecting these foot screws with each other. You can see here this tribe edge and the leveling head, right? So what this foot screws has to do? These three foot screws are provided between the trivet and tribe edge, and these are used for leveling, and by turning the foot screws the tribe edge can be raised or lowered to bring the bubble to the center of its run. What does it mean? This you can see here there is bubble tube, or the two bubble tubes are there. One is a cross bubble and another is a longitudinal bubble. These bubble tubes are simply used to make sure that whether this instrument is completely level, that means it is completely horizontal or not. If it is not, it is not going to give you that horizontal sight for the reading or for the observation, right? That's why it is always necessary to check whether an instrument is completely level or not, and that is to be done by checking these position of the bubble in your bubble tubes, right? So these bubbles can be taken in at its particular place by using these foot screws, and these foot screws, when you try to rotate them, it will try to change the position of this stripe edge, as you can see here in this figure, and that's how this will work as an instrument. The next one is known as a telescope. So telescope is something you can see here, that is on this side. So you can see this telescope, you can see here, that means this one, this is termed as a telescope. So telescope consists of two metal tubes generally, and one moving within inside of other, and it also consists of two different glasses. One is known as your object glass and another is known as your eyepiece, and these two different glasses are always located on the opposite end of each other, right? So let me talk about these glasses now. When these eyepiece is to be done, through which you have to see your object, right? So eyepiece are always available or fixed with a diaphragm, and diaphragm, you can see here, I have incorporated one figure. This diaphragm, if you see from the eyepiece, it will somewhat going to look like this. So this is the leveling staff on which you are going to take the readings. But if you see this particular line, the cross lines, vertical as well as horizontal, these are the horizontal crosshairs and the stadia hairs, and this thing is termed as a diaphragm. So this thing is always incorporated, is always fixed with here in this eyepiece, and this diaphragm adjustment ring is also available. So that is your first piece, and the second is nothing but is your object glass. And object glass is very simple. It will help you in focusing over your object, so that your object will appear very clearly, so that you can read your readings easily. And that's how these two glasses will work in your telescope. And that's all about your telescope. Then the next one is your bubble tubes. Bubble tubes, as I say, the bubble tubes are fixed on the top of the telescope, and the two bubble tubes, one called longitudinal bubble tube and the other, you can say, the cross bubble tube, you can see here, and they are placed at the right angles to each other. So this one, if this is your longitudinal bubble tube, your cross bubble tube is available at the right angle with each other, right? And the tubes contain the spirit bubble, and that means the bubble will try to change its position as you try to change the tilting of your telescope, tilting of the instrument. So what you need to do is the verticality of the instrument can be well checked by this cross bubble tube, whereas the horizontality of this instrument will be well checked by the longitudinal bubble tube, right? That's how these two bubble tubes will work, right? Then also there is one another feature or component available here in this dumpy level, is termed as a circular compass. So compass, so it is some instrument, compass is provided just below the telescope for the measuring the magnetic bearing of the line, or the, you can say, the angles, right? That's how this compass is going to work. But let's say in this discussion we are not going to talk about this use of compass, because it has been already discussed in their angular measurements, or it should be known to you. Then the next particular component here is nothing but is your axis of telescope and the line of collimation. Now what is this axis of telescope and line of collimation? For that I have incorporated another figure here. So this is another, this is your telescope, right? This is your eyepiece, this is your object glass, this is your leveling tube, right? So this is your dumpy level in short, right? So what do you mean by axis of telescope? The axis is an imaginary line, right? There is no actual line available. It's an imaginary line which is now passing through the optical center of the object glass as well as the optical center of the eyepiece. So that means if a line, if you try to see when it is passing through the optical center of these two glasses, then it is termed as the axis of telescope. And the line, if imaginary line passing through the intersection of this crosshair at the diaphragm and the optical center of the object glass and its continuation, that means it will continue until it will try to meet your object, so and then it is termed as a line of collimation. So this is a line of collimation, and if you consider the axis from this center to this center, then it is simply termed as your axis of bubble tube, right? So this is how these two different things is to be understand, axis of bubble tube and the line of collimation. Right, so this was all about your different components of this instrument, and this was all about the first instrument which is used. The second instrument which is used in the leveling is called as leveling staff. But before that, as I mentioned in the beginning, there are few other types of levels also available with us. There is Y level, reversible level, tinting level, and automatic level, right? So, and as I said that I'll give you a brief idea about this. Now, these different levels are something different with each other in terms of their manufacturing, right? So, let me give you an idea about it. Let's say if I talk about, let's say, tilting level. So, in case of dumpy level, the line of sight, as we have just seen, is perpendicular to the vertical axis. Once the instrument is level, the line of sight becomes the horizontal and the vertical axis becomes truly vertical, provided the instrument is in adjustment. But in the case of tilting level, however, the line of sight can be tilted slightly without tilting the vertical axis, and that's the advantageous thing over your dumpy level, right? There is another simple different types of level also available. The fifth one, you can say automatic level. This is the most advanced levels available nowadays, and they are in use, right? Dumpy levels are, you can say, they are obsoleted, but they are still in use for very reasonable small amount of work or very less accurate work, you can say. The total station or the automatic level are the levels which are simply give you all form of observations without more trouble, without more effort, right? And it will simply the adjustments, the verticality, the horizontality, everything is to be done quickly by automatically, and it will simply give you the readings on the screen itself. So it is not necessary to give you burden on your eyes to read those readings and other things. So that's how the automatic level will also work, right? But that's the advanced part of the surveying, and that has to be studied by the civil engineering students as their core subjects. As I said, I'm not going to discuss about that much more in more depth about this leveling, but rather I'll try to focus on different important topics, right? So moving further, the second instrument which is used in your leveling is termed as a leveling staff. So leveling staff is something, you can say, it is used for measuring the vertical distance between the points on the ground and the line of collimation. So that's how you will try to check, or you will try to determine the elevation or the height of this point by using the leveling staff, right? So leveling staff is you can say it's a straight rectangular rod having graduations on it, and the foot of this staff representing 0 reading, and your reading will start increasing as you move from the bottom to the top. The purpose of a level is to establish horizontal line of the side. Here the purpose of the leveling staff is to determine the amount by which the station or the point is above or below the line of sight. That means this is how the leveling staff will work, right? So now this leveling staffs may be divided into different classes. As you can see here, there are two different types of the classes of leveling staffs available with us. The first one is a self-reading staff, and the second one is a target staff, right? Now this is very simple to understand. A self-reading staff is the one which can be read directly by the instrument man through the telescope, and the target staff on the other hand contains a moving target against which the reading is taken by a staff man and not the instrument man, right? That's the difference between these self-reading staff and the target staff, right? So I'll give you a brief idea about this staff as well, how this staff will look like. So here you can see I have incorporated the actual photographs of this. So the self-reading staffs are now of three forms. The first one is a solid staff, second one is a folding staff, and you can say the third one is nothing but is your telescopic staff, right? So you can try to understand from the photograph itself, then it is very easy to understand, but still I'll give you certain idea about these different staffs which are used. Solid staffs are the first of all, the unit of the measurement will be metric here. So I'll just give you the discussion in terms of metric units only. So that's why it is also termed as a metric solid staff. So generally they are available in 3 meter long distance, 75 meter wide, and let's say 25 mm thick, and with a metal shoe at the bottom and graduated on one face, not on both the faces. Then you can say the folding staff is generally 4 meter long available and is divided into 2 equal parts or maybe more, and it is hinged at the middle so that the top half can be folded over the lie against the lower half, and that's how you can fold the complete staff in different layers. The third one is a telescopic staff. The telescopic staff consists of 2 hollow pieces and 1 solid top pieces, and each telescoping into the bottom one. That means when the staff is folded up, it is only a little longer than the lowest piece. right? As you can see here, when the upper sections are pulled out for the use, they are engaged and held by brass spring crutches, and it is thus longer than a solid staff, up to 4 meter to 6 meter, you can say. So for higher heights or for reasonably higher elevations, one can go for the telescopic staff. So for the higher range of the readings, when the instrument man is standing very far away from the point whose elevation has to be determined, one can use the telescopic staff, so it is well easy to read, right? That's how these different staffs will work. The next one is your target staff. Now target staff is the difference between your regular staff and the target staff is such that here the readings should be read by the target man, the man which is going to hold this staff, and not the instrument man on the other hand. That's the basic difference. So I'm not going to discuss about more of this stuff because this is something you need some form of information about it. So the target staff has a sliding target equipped with vernier, and which can be clamped at any point along the staff. As you can see, the circular one, this is your moving target or sliding target. And for taking the reading, the levelman directs the staffman to raise or lower the target until it is bisected and with the line of sight. So you can see here there are two different Vernier scales available, and generally these staffs are always available in a very limited height, right? So once you reach to the top height of this target staff, this first circular slider is fixed, and this second one is start in the use, and you will try to use this particular vernier, and the staffman will read the readings once your line of sight is bisected with the target, and that has to be indicated by the levelman, and the readings is to be taken. That's your target staff, right? So target staffs are rarely used, but generally nowadays the telescopic staffs are very preferable one. And as I mentioned, now for automatic level, the bit more advanced staffs are available, right? So there's something you can say prismatic staff and etc. So these are the different instruments of the leveling, you can say, used. But the simple, you need to make sure that you should remember the different types of it, right? Though we haven't discussed the detail of this each type, right? Now I'll discuss about the adjustments of the level. As I said before, taking the actual observations, right, you need to adjust your level. You need to make sure that your level, this level or this dumpy level is properly adjusted. It is ready to take the observation, right? And that temporary adjustments are something you can say it are made at every setup of the level before the staff readings are taken. Every setup. So when you are changing your position of the instrument from one to another, if you are changing your station from one to another, so that's how you need to adjust your level again and again and again every time before taking the reading. So which are these temporary adjustments now that I'll discuss with you, right? So if I talk about this temporary adjustment, they are very easy to understand, right? So as the temporary adjustments are done at each station, they are also called as station adjustments. And the temporary adjustments are, you can say, as you can see, there are three adjustments. First one is your selection of suitable position for setting up the level. Second one is your setting up, and the third one is a leveling up. And this leveling up is also now available or divided into two other types of adjustments, right? So what do you mean by selection of suitable position? Look, you have to select the position of the level in such a way that maximum number of readings can be taken without any difficulty. So that it's not necessary to change your position of the level again and again. And the ground should be fairly level and firm where you are going to place your instrument. The second adjustment called setting up is to be done. First of all, what you have to do, you have to set your tripod, and then on the top of it, or you can say the tripod is set up so that its top is at a convenient height, so that it is not difficult for you to see through the telescope. The tripod stand is placed at the required position with its leg well apart, and it is now pressed firmly into ground then. And what you need to do, the level is fixed on the top of the tripod stand. So you will try to check whether your instrument is looking level or horizontal or not with the help of tripod stand here. That's called level setting up. But that's not going to make sure that your instrument is completely horizontal. That means a line of sight that you will going to have from your telescope, it is horizontal. You need to make sure by having third adjustment, that is termed as your leveling up. And this leveling up is something, it is to be carried out for the purpose to make the vertical axis of the instruments truly vertical, so that it will be perpendicular to the line of sight. So how you will do it? You can do it by means of two different things. The first one is your approximate leveling by legs of the tripod stand. Right, what does it mean? You will try to change the position of the tripod legs, and you will try to make your bubble of the level tube or the leveling tube should come into the center. So what you need to do, right, that the legs of the tripod stand are something you can say is firmly fixed in the ground. What do you mean by that? You need to fix your three legs firmly into the ground. Then what you have to do, the third leg is moved to the left or right, in or out, and until the bubble is approximately at the center of its run, that is in the longitudinal bubble tube, right, as you can see here in this figure A and B. But this is not the first one. Once it is done with the help of tripod stands, you will try to finally check with the help of foot screws, as we have seen in the case of components of dumpy level. So the foot screws, you can see now here, this capital A, capital B, capital C, this one and this two, you can see here. These two figures are indicating the position of the foot screws, and this exercise is termed as the perfect leveling by foot screws. What you need to do? In first case, you have to turn the telescope so that the level tube is parallel to the any two foot screws. Here the level tube is parallel to these A and B. It may be parallel to the A and C. You can try to keep parallel to the B and C as well, whatever is convenient to you. Then what you have to do, is the exercise is very simple. Turn these two screws which are now parallel to your level tube either towards in or try to turn towards out until your bubble comes in the center of the level tube. Once it is at the center of the bubble tube, what you will do for the next step, you will try to make your bubble tube now perpendicular to these two foot screws, and now you will try to check the center of the bubble with the help of the remaining foot screw, that is your capital C. So now you will try to rotate your foot screw, that is the capital C foot screw, which was not utilized in the first case, and you will try to take your bubble into the center, and that's how once it is in the center, you can try to rotate your telescope at any particular direction, and you will see your bubble will remain in the center, exactly center in the leveling tube. Then and then only you can say your level is now completely level. Dumpy level is perfectly set up for the observation, and then you can go for the other adjustments. Why other adjustment? Because this is something you made your instrument completely horizontal till it is not ready for the observation. So for observation, you have to go for some other adjustments as well, and that adjustments are termed as your focusing the eyepiece and focusing the object glass. Now focusing the eyepiece and focusing the object glass is also again very simple to understand. What does it mean? Focusing the eyepiece and object glass, as I said, that the eyepiece is now available with the diaphragm wall. So what you have to do for this thing, you need to rotate your eyepiece in such a way that once you see your diaphragm is coming completely clear, right? As we have seen in this figure you can see here this diaphragm is completely visible. So you need to rotate your eyepiece in such a way that you can see your diaphragm completely clear. And how you can do it? You can place a white paper on the object glass so that you can see these crosshairs or the diaphragm clearly. And once it is completely focused, your first or the fourth operation is done, that is your adjusting the eyepiece. Then you need to focus your object glass, because once you have focused your eyepiece, then also if you try to observe your object through the telescope, it may be seeing, or it may be visible as a blurry one. So then you have to observe, or then you have to adjust your objective glass to make your object visible, clear. And once it is clear, then and then you can finally read your observation. And that's how the adjustments to be done for your dumpy level before taking any staff reading, but when you have changed the position of your instrument from one to another, right? So that's how you need to take care. The selection of the staff, this particular point on which you are going to put your instrument, then it is very important, because you need to cover, or you want to cover as many points from that one single particular instrument station, so that these temporary adjustments are avoided to be done every time, right? So these are the different adjustments of the leveling, you can say. Now after this adjustment, the next particular part that I have to discuss about is the application. Now as we'll move from the introduction to the application part of this leveling. So that will going to be the more of technical discussion. So that will basically start with the different methods or the types of leveling available with this. So generally, what does it mean? The simple different types of levelings or the classification of our levelings are already done, and as you can see here mentioned on the screen, these are the different classification of the leveling. So I'm going to discuss about this classification now, and I'll give you different idea about different types of as well. So three principal methods are used, or the classifications are there for leveling, and is to determine the difference in elevation, and they are namely termed as your direct leveling, which is also known as spirit leveling. Second one is your trigonometric leveling, which is also termed as your indirect leveling, and the third one is your biometric leveling, right? There is one another also type of leveling is also available, which is known as hypsometric leveling. I'll give you idea about that as well. So this different leveling and the methods of leveling I'm going to discuss in my next video, and along with the remaining part of the leveling, and I'll discuss about the examples as well, right? So that's all for this video. I hope you understood the introduction of leveling very well, and if you have any doubts or if you have any problem, you can refer some other references or other books or other textbooks as well, right? Thank you.